Now let's just move on further towards the topic which is nothing but called as the parallel lines and transversal. So what is the meaning of a transversal? Let us suppose we'll see it first. So a line which intersects two or more lines at the distinct points is nothing but called as a transversal. So we already know about this definition. Let us suppose if I'm just taking two or more lines in such a manner. So this particular line that is intersecting these two lines at the two distinct points is actually called as nothing but a transversal. So this line is called as nothing but a transversal, and these two are nothing but called as the parallel lines, because if we can take any particular 2 points on these line and will join these 2 points such that it will form a perpendicular, then the distance or the length within these two particular lines should always be the same if I'll take any 2 particular points on these 2 lines. So hence these are nothing but called as the parallel line, in which the distance between the 2 lines throughout the lines is remain the same. Those lines are actually called as nothing but the parallel lines. So this is nothing but all about the transversal line and a parallel line. Now let us suppose if I'm just taking any particular example in which I'm taking a line L which is intersecting the 2 lines M and N at the points P and Q. So let us suppose this is my figure that I am getting. I do have the 2 lines, that is M and N, and there is a line L which is intersecting this particular M and N at 2 distinct points. This is the point P, this is the point Q, and at the point P and at the point Q you can see there are 4 angles that are forming, 4 angles over here and 4 angles over here. So what can we say about these 4 angles? So first of all, let us suppose if I am just talking about the exterior angles. So what are exterior angles? So the angle 1, 2, 7, 8 that are in the exterior region, means 1, 2, as you can see these are 1, 2, this is 8, 7, 1, 2 angle and 8, 7 angle, they are nothing but called as the exterior angles. So always remember, whenever we have such a scenario in which we have a transversal, we have the 2 lines over here such that the transversal is intersecting these 2 lines at 2 distinct points, and the angles that would form over there such that 1, 2 and 7, 8 angles are in the exterior portion, so they are nothing but called as the exterior angles. So if I'm just talking about the exterior angles, so it is quite obvious about the interior angles. So what are interior angles? That are interior in this region, or that are lying in the interior of this region. So as you can see, if I'm just talking about this particular region, so in the interior we have these 4 angles, that is angle 3, angle 4, angle 5, angle 6. So they are nothing but called as the interior angles. So we have the 2 special type of angles over here. First of all, we have learned the exterior angles, and the second is nothing but interior angles. So let us suppose if I'm just recalling the angles that we already are aware about. So first of all, let us suppose if I'm just taking a figure in such a manner that I have 2 parallel lines, that is M and N, such that L is intersecting this particular line, and there are some angles that are forming, that is 1, 2, 3, 4, 5, 6, 7, 8. So we already know about the angle 1 and angle 2, and angle 7 and 8, they are nothing but called as the exterior angles. Furthermore, we know that the angle 3, 4, 5, 6, they are nothing but called as the interior angles. So apart from these 2 angles, we already know that there are other angles in this particular figure. So what are those? Let us suppose if I'm just taking the very first angle we are already aware about, which is nothing but called as the corresponding angles. Yes. What are the corresponding angles? We know that the corresponding angles are nothing but angle 1 and angle 5, angle 2 and angle 6. You can see over here, these are nothing but called as the corresponding angles, that is 1, 5, 2, 6, 4, 8, 3, 7. They are nothing but called as the corresponding angles that are lying in between these 2 parallel lines and a transversal. Furthermore, there are some other angles which are called as the alternate interior angles. So we have alternate interior angles over here, which is nothing but angle 4, angle 6, angle 3 and angle 4. This is nothing but called as the alternate interior angles that are formed in between the 2 parallel lines and a transversal. Furthermore, we know about the alternate exterior angles. So what are alternate exterior angles? Angle 1 and angle 7 are called as the alternate exterior angles. Angle 2 and angle 8, they are nothing but called as the alternate exterior angles that we already are aware about. Furthermore, we know about other type of angles that are called as interior angles on the same side of the transversal. So what are the interior angles in the same side of the transversal? If I'm just talking about this transversal, so on the same side of transversal in the interior region means these two angles, that is angle 4, angle 5. Furthermore, this angle 3 and angle 6. So these two angles and these two angles are nothing but called as the interior angles on the same side of the transversal. So they are nothing but called as the interior angles on the same side of the transversal. So we already are aware about such kind of angles. Now let us suppose if I'm just talking about this particular figure again. If I'm just talking about this particular figure again, and if I will draw this particular figure on my notebook, in which we already know that there are some ruled lines in our notebook, and they are actually parallel to each other. And furthermore, if I'll draw a transversal from those two ruled lines, then I can see that, or I can measure all by myself that these angles, that is nothing but angle 1, angle 5 and angle 2 and angle 6. So here I'm talking about the specific angles that are called as the corresponding angles. So after drawing, I will definitely verify this thing that the angle 1 should comes out to be equal to the angle 5. The angle 2 should comes out to be equal to the angle 6. So angle 4 should be equal to the angle 8 and angle 3 should comes out to be equal to the angle 7. So from this type of activity, what can I conclude? I can conclude a very important thing. First of all, let us suppose if I'm just talking about the allied angles first, that the interior angles on the same side of the transversal, they are also referred to as the consecutive interior angles or allied angles or co-interior angles. So if it is given to us that they are allied angles, so don't get worried about this, that what are allied angles. Allied angles are just same as that of the interior angles that are on the same side of the transversal. So this is a very special note which is related with this figure. So let us suppose if I'm just coming out with my activity again. So from my activity, what I have concluded that the corresponding angles are actually coming out to be equal to each other when I have drawn a transversal on my notebook which do have the ruled lines on it. So from that particular activity, I can conclude that if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. So since we have done with the activity in which I have taken the two particular lines that are in our notebook, which is called as the ruled lines. We already have the ruled lines in our notebook, and when we can draw a transversal from the two ruled lines, then I can definitely find this thing that the corresponding angles are coming out to be equal to each other, which leads us towards this axiom which says that if a transversal intersects two parallel lines, then each pair of corresponding angles is equal to each other. So hence this axiom is actually called as nothing but a corresponding angles axiom. This axiom do have a special name which is nothing but called as the corresponding angles axiom. So let us suppose if I'm just talking about the converse of this particular axiom. Let us suppose if I'm just talking about the converse, which says if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. So here we have a condition that a pair of corresponding angles are equal, and we have to prove that the two lines are parallel to each other or not. So let us suppose if I'll just prove that whether this converse is true or not through an activity again, because we do not know about this converse, that whether it is true or false. So let us suppose if I'm just performing another type of an activity again, and I'm just taking a straight line over here. Let us suppose if I'm just taking a straight line AD such that I'm taking two rays on it. I'm taking two rays on it in such a way that the corresponding angles, means this angle and this angle, is equal to each other, means the corresponding angles are equal to each other. So for this particular activity, activity, I'm just taking a straight line AD such that there are two rays on it. I am drawing these two rays in such a manner that these two angles are actually is equal to each other. So if these two angles are equal to each other, so I'm extending these two lines further, and I'm extending these two lines further. So let us suppose this is the figure that I'm getting after extending QB and SC towards P and R, such that if I'll measure the distance between these two particular lines, if I'll measure the distance between these two particular lines, remember the distance must be perpendicular. If I will measure the distance or the perpendicular distance in between these two lines, let us suppose if I'm talking about this distance, and further goes on the distance between these two particular lines, then that distance will come out to be equal to each other at any two particular points. So it means throughout these two lines, the distance between the two lines remains the same, which definitely implies that these two lines are actually parallel to each other. And hence, this particular activity actually proved our theorem, which leads us towards the axiom again, which is nothing but the converse of our previous axiom. And this axiom says that if a transversal intersect the lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. So this is nothing but the converse of the previous axiom. So this is all about this activity, in which we have talked about the corresponding angles axiom and the converse of it.